Hello, everybody. Let's talk about VSEPR, valence shell electron pair repulsion theory, also known as molecular geometry. So, the shape of a molecule is important because it helps determine its reactivity. Electrons repel other electrons. They all have a negative charge. Like charges repel, opposite charges attract. VSEPR assumes that the shape of a molecule is determined by the repulsion of electron pairs. So if you have electrons pushing each other away, then it's going to make the angles change. So it's based on electron dot Lewis structures. It predicts the shapes. And we call it VSEPR because valence shell electron pair repulsion is a lot to say. Okay. Electrons around the central nucleus repel each other, so structures have atoms maximally spread out. The main shapes that we will talk about: tetrahedral. It means that it has four surrounding molecules. Trigonal has three surrounding atoms. Bent, it has two. Trigonal pyramidal, it has three surrounding, but it also has a lone pair at the top. The lone pair makes it crown up. And linear. Linear is a straight line. There's two of them. There can be three in a straight line. So let's look at the angles. For a linear, the angle is going to be 180 degrees. For a bent, the angle is going to be 109.5 most of the time. The lone pairs that we see will cause additional bending. If there was only these two, then we'd have 109. But the fact that we have two lone pairs here, it pushes the angles away. Okay, 120, because they're all equal. Now this one, because of the lone pair of electrons, it's going to push these angles. And once it pushes this one, it's going to push the other ones. And tetrahedral, the angles are all the same. So anytime you see a linear, the angle's 180. Anytime you see a bent, it's going to be 109.5, or with certain cases like water, 104.5. Trigonal planar, it's equal, 120, 120, 120. Trigonal pyramidal, it's going to be 107, 106.5, depending on the lone pair. In tetrahedral, it's going to be 109.5 degrees.